Hello, hello, hello. Hello, hello. Hello, hello. Hello, hello. Who's here? Who is here? Show yourself. Who is here? Hello, hello, hello. Who is here? Come say hello. Come say hello. Who is here? Where are my students? Where are my students? Where are my students? Say hello so I know you're here. I'm going to wait. Come say hello. Come say hello. Come say hello. Alright, Ryan's here. Good. I was worried nobody was here. Hi, Ryan. Welcome, welcome. Who else is here? Hi, Ryan. How was your weekend? Who else is here? We have two people here. Who is our other student here? We have Ryan and someone else is here too. Who else is here? Who else is here? Who else is here? Ryan, tell me your question. Answer my question. How was your weekend? Tell me how was your weekend? And who else is here? Where are my other students? Everybody say hello in the chat. Who else is here? Ryan, you exercised with your family this weekend. That sounds like fun. I like that. I like to exercise with my family too. I haven't seen my family in a long time. What kind of exercise? I like running. Running is my favorite exercise. Sometimes playing soccer also. These sorts of things.
Did anybody get it?
Who else? Only Ryan is here.
Only Ryan is here?
Says there are 4 people watching, but only Ryan has said hello.
Really?
I don't know where the others are.
Few students are said they will be a little late because they went to the math academy.
Oh,
Okay.
Who should I expect for this class?
G4 classes like gold class.
Gold. Okay.
John Woojin, Daniel
Okay.
Jun, and Ryan and Daniel Lee, Sang
DJ.
right?
Okay. Okay. Sure.
And some kind of
Daniel
maybe
Lee.
Jay on Saturday class.
So
like that.
more people. All right. DJ Daniel is watching. Good. DJ. Bow, bow, bow. DJ, how was your weekend? What did you do? Anything fun? Do anything fun on the weekend, DJ? Tell me. What did you do? Ryan did some kind of walking on the weekend. I love walking too. I can walk all day. I like to walk. Walk and walk and walk. I like walking 50 kilometers. I can walk forever. I love walking. It's so much fun and you can see everything. I like walking in the mountains, in the country. Walking in the city is nice too. Okay. We're expecting some more people. I don't know who else there is. We have Daniel and Ryan. Who else is here? We have 4 people watching the stream. make sure you say hello. You need to say hello. I'm taking attendance. I have to write down who is watching the class, okay? I have to write down who is watching the class. So you other two people, you need to say who you are. So I know who's here. I need to take attendance. Daniel and Ryan are here. Who else? Daniel went to Pyeongchang. Oh, I don't know what it is, but mountain. Nice. That sounds good. That sounds like a good weekend. Good, good, good. I'm glad that you had a good weekend too. Who else is here? Who else is here? Say hello in the chat. The 4 people watching. So say hello in the chat. Okay? 4 people watching. 2 is Daniel. Daniel, you have 2. You have a phone and a computer or something? There's 2 of you. I see. I see. That makes sense. Alright. Then maybe we should get started then. Maybe we should get started. Alright. So let's look here. Today we're going to be doing some kind of science reading. Hopefully. I like science. Hopefully you do too. I like science. I like science reading. We can do English while learning science. Fun, fun, fun. Ah, you have your phone and your computer, you do. Alright. This is what we're doing today. Let me show you. Alright. This is what we're doing. We're doing earth structure. We're learning about the earth. How is the earth made? What is the shape of the earth? What are the pieces of the earth? One is your phone, one is your computer. Okay. Right. How is the earth put together? Things like that. This is what we're trying to understand in Earth's structure. Okay. So, Earth's structure. Structure is a word kind of like shape. How is something made? Like a building is also a structure. What is the structure of the building? What is its shape? What are the pieces? How is it made? We're trying to understand about the earth. What is the earth's structure? What is its shape? What are its pieces? How is it made? Okay? And we're going to look at that, all big ideas here. Okay. So, let's look at this. You've probably seen this before like this. This is the earth. If we cut the earth open, we can see what does it look like in the middle. Oh, what page? You don't have this book. You don't have this book, so you just have to look and watch my computer. Watch your screen and you can see it. Okay, you don't have this book. Okay? So here the earth structure, what is the earth's shape? How is it made? If we cut it open, we can see 1, 2, 3, 4 layers to the earth. Okay? We have this part, the outside where we live. We can see some water and the land. Here's Africa, right? In Greenland. We can see the outside of the earth. This thin little piece is called the crust. The crust is the very outside. Just like the crust of pizza. The crust of pizza is on the outside. The crust of earth is on the outside. Okay? The crust is rocks and dirt and trees and water and grass. All like that on the outside. It's like the temperature of the air. It's not super hot. Okay? it can actually be very cold in some places on the crust. Under the crust, underneath this rocks and dirt and water, there is this thing called the mantle. This mantle, I shouldn't use that color, that'll be confusing. This mantle is the thickest part. The mantle is the thickest part of the earth, right? The biggest part. The mantle is lots of magma in different pieces here. Okay? We'll see about that. And then we have the outer core. Core means middle. So this orange and red together is the core. We have the outer core and the inner core. We're going to understand that by reading here. Okay? So I'm going to read this here. And while I'm reading, I want you to be reading also, so we can read together. Alright? I want you to be reading out loud while I'm reading out loud. Don't just listen to me. Don't just listen to me. Okay? You don't have this book. I don't think you have this book. Okay? So let's read this together. Let's read this together. Follow along. Planet Earth began to form an amazing 4.6 billion years ago. Scientists believe it probably formed when a mass of rocky debris circling the sun smashed together to make a planet. Okay. This debris means, oops, I'll use a different color. This debris means pieces of rock. All these pieces of rock just floating around the sun, they smash together to make a planet. These collisions means crashes, these collisions created heat, which made our young planet white hot. They crashed together and they hit each other so hard that the planet was very hot. Earth's outer crust has now cooled and hardened, but red-hot liquid rock still lies below the surface. Okay. Down here is all red-hot liquid rock, like magma, which you see coming out of a volcano. That red-hot liquid rock is down there. The outer crust is not one smooth layer, but is made up of giant sections called plates, which fit together. Okay? Alright, so here we can see, lift the flap on the globe to see Earth's interior. Interior means inside. Below the crust is a red-hot layer called the mantle. Mantle, and then below that is the outer core and inner core. What we see here is that, like it says, the crust is not one smooth layer, but is made up of giant sections called plates, right? So if we look at this picture, it's a map. Why is this not working? Why is it not working? Okay. And the pieces of the crust fit together like puzzle pieces, right? This is one piece. Here's another piece. Here's a very big piece. Right? Here's a big piece. Here's another one. And another one. And another piece. Right? The pieces of the Earth's crust fit together like puzzle pieces. Okay? This is what we're understanding. There are all these big puzzle pieces that stick together like this. Alright? If you look at the picture, you can understand that. These big puzzle pieces stick together in this way. Oops. That's how it works. You might have learned this before. This kind of idea. We call them plates. They fit together. What is the name of the plate? What is the name of the plate that Korea is on? Who can tell me? What is the name of the plate that Korea is on? Answer the question. Who can tell me what is the name of the plate Korea is on? Somebody please tell me. What is the name of the plate that Korea is on? Somebody answer. Tree. June tree. No. We have here the names of the plates. Alright, so this is the North American plate. Juan de Fuca plate, Cocos plate, Caribbean plate. Alright, Ryan's got our correct answer. Ryan says the Eurasian plate. Yes, this plate here, let me see here. This one, the Eurasian plate. This is what Korea is on, right? Korea is on the Eurasian plate. Good. This is the other half. This is part of the same plate. I don't know why they cut it in half. Okay? Alright. So there, exactly. We're on the Eurasian plate here. You can see the reason why there are so many earthquakes here and in Japan. In Japan there are lots of earthquakes because that's where this line is. Where these lines are where there are more earthquakes than other places. Lots of earthquakes and volcanoes happen on these lines. So if you look at the middle of it, for example here in the middle, here's the US, there aren't a lot of earthquakes or volcanoes here. But over here we have volcanoes, and here lots of earthquakes here, right? Lots of volcanoes here, lots of volcanoes here, right? That's why we have earthquakes and volcanoes, because where the plates touch together is where the magma can come up to those places. That's why there are volcanoes there. And where the plates rub together, that's where we can get earthquakes. Okay? Alright. So we call these tectonic plates. Let's read this together, okay? While I read, you read along. Tectonic plates. Earth's crust is made up of about 17 rocky sections called tectonic plates, which fit together like a puzzle. These plates are not fixed in one place. Churning movements in the molten rock of the mantle below create circular flows called convection currents. This is a difficult sentence, isn't it? Kind of a long, difficult sentence. We'll explain this later. These cause the plates to move across Earth's surface at a rate of about half an inch per year. Alright, so let me explain this a little bit. We saw here that here underneath this is all liquid. This is all here. We have here that underneath it's all mixing together, so it makes like circles like this. And maybe this will make circles like this. There are circles, currents in the convection. And so when this one spins this way, it pushes the crust this way. And this one, convection currents. Let me show you. Convection currents, mantle. Right. So we look at this, right? Here, the outside of the Earth, we have the convection current. Convection current, this is moving, this molten lava, this magma is spinning like this. And it's pushing this plate, pushing it this way. And this one's spinning like this, it's pushing this one this way. We can see here that then where it pulls apart, then the magma can come up through, and there's going to be a volcano here like this. And where it's pushing into this one goes underneath, and it makes this deep trench, pulling it down like that. Okay? You can see some example. Oh, here's another good example. Right? You can see the mantle, this lava is moving like this in a circle. It's just moving like this. So this one here is pushing into it. There's volcanoes. Here it's splitting apart, and there's ridges, right, where the magma is coming through. Okay? Alright, so they move about half an inch per year. So only like 1 centimeter every year. Every year the plates move a little bit like that. So all these plates, they move around, they push into each other. Remember, a long time ago, all of the land in the world was all stuck together, right? All the land in the world stuck together, and slowly, they move around, and now it looks like this, right? It used to all be pushed together, now it splits apart. Okay. Alright, let's keep reading. Here's an experiment. Ooh, we'll see this here. Okay. We're not going to do this experiment, but we can explain it. So, this experiment to create convection currents. These convection currents are the circular movement in the water or lava. You will need a pan of warm water. Here's our pan. 3 cups, 1, 2, 3, red and green food coloring, and a dropper. Okay. Water flows in a similar way to molten rock in the mantle. Place the pan of warm water on 2 cups turned upside down with a 1/3 cup of hot water in the middle. Ask an adult to help with hot water. Put a drop of green color in the middle of the pan and another red drop near the edge. Watch how heat in the center makes the water flow around in a circle. We will see here, okay, what's going to happen to this green drop? Well, this is hot, right? This water is hot. This water is hot. So the heat's going to come up here and make this water hot. And when this water gets hot, we know just like hot air balloons, hot things move up. Hot things move up. So this is going to move up like this. and then some is going to come this way, and some is going to come this way. But it's hot, so it's moving up. And then when it comes here, it's going to get colder, right? Then it's going to get colder, right? Colder and colder up by the cool air. So here it's hot, and then it gets colder, and then it gets more cold, and then it comes down here, and then here, now it gets hot again, and then the heat comes up here, it makes the water hot again, and it makes a circle like this. It gets hot, so it comes up, and then it gets cold, so it goes down, and it gets hot, so it comes up, and gets cold, so it goes down. What we call convection currents. These are all over the world. We have in the mantle, the magma, the molten liquid rock makes convection currents. But also in the ocean, we have lots of convection currents. From the heat of the sun on the water and the salt, it makes more convection currents in the ocean also. Okay? That's why the water is all moving around in the ocean. Right, so here, let's talk about this again. Churning movements. Churning is this kind of feeling of the movement in the inside of the water, or here it's molten rock, of the mantle below creates these circular flows. Right? This circular flows called convection currents. And these currents push these plates around on the surface. Okay, we call these plates tectonic plates. Alright, next one. We're going to see this, how plates move. So here we have an example of a plate. We have an example of a plate here. The mantle here and the crust up top. Alright, here we have a boat. Alright, let's read this all together. Read it all together. How tectonic plates move. Tectonic plates slowly drift across the globe. The places where they meet are called plate boundaries or plate borders. Boundaries and borders has the same meaning. They both mean the edge of something, the outside of something. Plate boundaries. Where two plates crash together, one dives below the other. Deep underground, the rock melts, then rises up again to make a volcano. In other places, plates scrape past one another or drift apart. Okay? So we see here slowly drift. Drift means to move. The plates slowly move around the globe. The places where they meet, plate boundary or plate border. They crash together. Look, this one goes underneath like this. They're pushing together, and this one goes under. Deep underground, the rock melts. Okay? So this rock melts here, and then pushes up to make the volcano like this. In other places, the plates can scrape past each other. Some places the plate's moving this way, and this plate's moving this way. Here they're pushing into each other. But some places one moves this way, one moves this way. We have really strong earthquakes when they do that. Or drift apart means this one goes this way, this one goes this way. That's what it means, drift apart, move away from each other. Hi, Sean. Hi, Sean. Good, we only have 3 people still? 5 people, we have 3 people. Alright, Sean, we're learning about tectonic plates today. We're learning about tectonic plates and Earth's structure. Someone tell me. Okay. Explain to me what is a tectonic plate. Who can tell me? Somebody answer the question. This is your quiz. What is a tectonic plate? What did we learn? Alright, 17 rocky sections are tectonic plates. That's what it says here. 17 rocky sections. Sections of what? Tectonic plates are sections of what? Oh, Hyunu's here too. Hello, Hyunu. Tectonic plates are sections of what? Sections of schools? Sections of my kitchen? Sections of what? Tectonic plates are rocky sections of what? What are the tectonic plates pieces of? Somebody answer the question. What are the tectonic plates pieces of? They are rocky pieces of Can someone answer the question? Crust. Alright. Tectonic plates are rocky sections of the Earth's crust. Right? They are sections of the Earth's crust that lock together or that fit together like puzzle pieces. Right? These are the tectonic plates, the sections of the Earth's crust. Alright. Good. Alright, let's ask another question. Let's have everybody answer this question. Well, Sean and Hyunu just joined us, so maybe we should read some of this again. Okay. Now that we read that, I'm going to read it one more time because Sean and Hyunu just joined us. Sean and Hyunu, we're reading about tectonic plates and the crust. I'll read this one more time here, okay? Read along with me, don't just sit there quietly. Planet Earth began to form an amazing 4.6 billion years ago. Scientists believe it probably formed when a mass of rocky debris circling the sun smashed together to make a planet. These collisions created heat, which made the young planet white hot. Earth's outer crust has now cooled and hardened, but red-hot liquid rock still lies below the surface. The outer crust is not one smooth layer, but is made up of giant sections called plates, which fit together. Lift the flap on the globe to see Earth's interior, inside. Below the crust is a red-hot layer called the mantle. Below that is the outer and then the inner core. Okay? So who can tell me, how was the Earth formed? How was the Earth made? In a test tube? Did a person make it? Alright, Ryan's got an answer. Where's everybody else? Sean, Daniel, Hyunwoo. You guys have to answer the questions too. I only have Ryan's answer. Why do I only have Ryan's answer? You guys should all be typing your answers. Okay? Alright. Rocky debris. Remember, debris is like pieces. Debris means little pieces of something. Okay? All this rocky debris smashed together, flying around the sun super fast, all crashes together to make a planet. A Big Bang itself was not when the Earth was made. The Earth was made pretty long after the Big Bang. Big Bang happened, and then the Earth was made 4.6 billion years ago. Alright? Big Bang was before that. Okay. But then around the sun, right? Maybe we can see. Oh, right? Right? Look at this. We have all these rocks, and they smash together, and then another big one smashes into that. Boom, smashes into that. They hit each other so hard that it makes it really, really hot. Okay? All crashing into each other. These things, boom. Right? That also made the earth, the moon. Right? When these big pieces of rocks smash into each other, people think that's how the moon was made. Also, must have been a very intense time. Nothing could live there. It was so hot. Okay? Alright. So we see here, we see the mantle. This is all melted rock. The magma down here in the mantle. Red hot melted rock. So we were talking about convection currents. This is a very important idea. Let me explain it again. I explained before Hyunwoo and Sean joined the class. Okay. Convection currents. Right. Earth's crust is made up of about 17 rocky sections called tectonic plates, which fit together like a puzzle. These plates are not fixed in one place. Turning movements in the molten rock of the mantle below create circular flows called convection currents. Okay, so movement in the molten rock, the liquid rock in the mantle makes circular flows called convection currents. Right. Let me explain how that would work here. Here we have a pan of warm water. This is a pan of warm water. We have hot water in here. Okay, this is hot. Hot in the, oh, too wide. The water is hot in the middle. Right, so the heat is coming in from here up to here, okay? The heat is coming in. And here we just have warm water. We know what happens when we make a liquid or a gas warm is it starts to float, right? This starts to get hot, and so it moves up, moves up, moves up. And then when it goes here, then it starts to go this way. Starts to flow, right? And then, as this hot water is touching the air, then it starts to cool down, right? Cools down. And then it cools down so much, it gets cold again, and then it gets pushed down like this. Pushed down like this. But then here, there's the heat is coming up. So here it warms up a little bit again, warms up, and then it comes hot again and moves back around. So because of this, what happens, we'll see that the water would move in a circle like this. Here the heat pushes it up, and then it cools down, and then comes back around. Heat heats it up, and it comes around. So you get these movements like that. We have the same thing in the mantle like this. So underneath the Earth's crust, underneath the outside layer of the rocks and the ocean and the dirt and the trees and the people and the cities, underneath that, this is all liquid rock, magma. And it's moving in circles like this. These convection currents. It's moving in circles like this. And this is why it's hottest over here, pushes it, and here it goes this way, and then cools down and comes down. And it's hot again, and it comes up like this. Well, what happens as this is pushing in a circle like this, it pushes this plate this way, pushes it, and this one comes this way, and the magma slowly pushes on this rock. The rock moves this way. The crust moves this way. So as it's being pulled apart, then the magma can come up through the middle, in the crack in the middle, into the ocean or into a volcano like this, right? Same thing over here. Here's the plate, the rock, and you're pushed underneath. Pushed underneath. And where it's crushing together, Then it makes the volcanoes, because this is all melted and it cracks. And it comes out through out here and it makes the volcanoes and the trenches, the deep parts like this, where they run into each other. But they move because of these convection currents, just like this. Right? These convection currents happen in the magma. Convection currents also happen in the air. And convection currents also happen in the ocean. The ocean is mixing together because of these same kinds of convection currents. Okay, it's a really important idea in science about these things moving around like this. Right, so we saw this one like this. The tectonic plates slowly drift. They move around the globe. They meet, it's called a plate boundary or plate border. Boundary and border means the edge of two things, like a wall or a line between two places. When the two plates crash together, one dives below the other one. We see that here. This one goes on top, this one goes under. Deep underground, the rock melts. So this gets really hot from them crushing into each other. So this melts and then comes out in a volcano. Okay? In other places, the plates can scrape into each other. One can move this way and one can move this way. Or they can move away, one moves away and one moves this away. Right? But all of the plates of the earth, all of these plates here are moving like this. They're all moving different directions. I don't remember in which way exactly they're moving. I think this one's moving this way and this one's moving this way. I think so. I don't remember what else. I don't remember how else the other ones are moving. I forgot. But there are all these different pieces like this. And where they crash together, then they can make volcanoes. That's why there are many volcanoes along this line. Volcanoes here. Many volcanoes over here too. Volcanoes around here. Volcanoes here. Right? But there are no volcanoes in the middle because it's all just the middle of the plate. Okay? Let's have our break, a 10-minute break now, and then we'll start onto the next one after break, okay? Break time until 5 o'clock. Alright, and then you can ask questions and we'll talk about it. Alright?
How many students are here?
4.
4 answering, then
just
how many
have
watching?
Ryan and Daniel, Hyunwoo, and Sean. Daniel has on 2 accounts, but there's still
Which
one
Daniel?
person unaccounted for. Daniel J.
Daniel Jump?
Mm-hmm.
What about Daniel Lee here? Is he here
Not
too?
yet. No.
He's just watching?
Alright, students. Who's here? Who is here? Who is here? What's up, everybody? Break time's over. Everyone back. Alright, when you're back, say hello. When you're back, say hello. So I know you're back. So I know you're back. Ryan's back. Sean is back. Where's Daniel? Where's Hyunwoo? Are you back? Are you back? Tell me, tell me. What's up? You can't see the screen. Oh. It's me. Can you see me now? It was set on the break time screen before. Now I'm back. Where is Daniel? Daniel, are you back? 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 Where's Daniel? How many people here? 6 people watching. Only 3 people here. Where is Daniel? DJ Daniel J, where are you? Come say hello so I know you are listening. Where are you? I can't find you. Where are you, Daniel? Daniel. Okay, Daniel's here. Okay. Good. Good. So we're gonna get started. Now, last time, remember, we read about tectonic plates. Remember what we talked about? The Earth is split, the crust, the outside layer is split into 17 sections that fit together like puzzle pieces, and they move around, they crash into each other, they slide into each other. That's why we have earthquakes and volcanoes. Remember, underneath the plates is all magma, right? Liquid flowing underneath, okay? And it moves in a circle called a convection current, and this convection current pushes the plates. So when they push together, they can make mountains, or one can go over the other one, or like that. Or they can pull apart, and then the magma comes out in the middle, right? Okay. Next, we're going to talk about mountains. How mountains are made, okay? We're going to talk about mountains and volcanoes, all the different ways, different kinds of mountains, things like that. Okay, there are different ways that mountains are made. So let's talk about this. Making mountains. Alright, let's read all together. I will read. I want you to read as well so we can read together. Making mountains. Mountains form in 3 main ways: through folding of rock layers, volcanic activity, and when blocks of land are forced upward. Mount Everest, the highest peak on land, stands 29,000 feet above sea level. But Earth's highest mountains are found on the seabed. The peaks of the volcanic islands of Hawaii rise over 33,000 feet from the seabed. Okay, what they're saying here, right? They're saying that Hawaii is taller than Mount Everest? What does that mean, right? Let's explain. So we have Mount Everest. Here's the land. So here's India and China and Tibet and Nepal. And then the mountain comes. You can't see that. Why can't you see that? Let me try it again. Okay. So here's the land, and then the mountain comes up out of the land, right? Right. And here's the water. Here's the water, like this. Here's the ocean. Okay. And what they're saying is that this, basically the highest mountain is 29K. 29,000 feet, right? But that's not the tallest mountain, they say, because down here we have, from the bottom of the ocean, we have like this. And here, right, this is like Hawaii. This is Hawaii. And what they're saying is that from here to here is 33K feet. So even though Hawaii is not as tall like this out of the water from here, like, right, Everest is much higher in the sky, but they're saying that Hawaii is a taller mountain like this. Okay. 33,000 feet from the seabed. This is the seabed. Alright. Block mountains. This is the first one we'll talk about. Block mountains form where a slab of land is pushed upward between two faults, deep cracks in the crust, usually found near plate borders. Where a block of land drops down between two faults, it forms a rift valley. Okay, so we have here, in this place here, we have these faults, these parts of the ground that are, there's cracks in the ground, right? These parts of the ground are pushed down like this, but these push together kind of like this, and this one is pushed up like this, and this makes a block mountain. Okay? Let's see some examples. I just spelled mountain wrong. I wrote mountain. Block mountain. Here's kind of an example of what some mountain looks like. You can see the rock. Mountain. Alright, so here are some examples of block mountains, right? Well, here you can see here between the fault lines, pushed down in the crack here. And so this is pushed up like in between the cracks. There's another crack on the other side like this. So this makes the block mountains. Okay? Like this too, block mountains. The cracks and this is pushed up. You see, that's usually how it looks. You can see the layers in it like this. You can see it stays up and down, these layers in the rock. That, right? You can see the layers in the rock. Okay. Oh, here's mountain ranges. Right? We didn't talk about this. High mountains are found on every continent. Find the Rocky Mountains in North America. Rocky Mountains over here. The Andes in South America, down here. I've been to the Rocky Mountains. It's very beautiful. It's in like Wyoming and Utah and Colorado. Very beautiful mountains. Andes are down here in like Peru and Bolivia. Also very beautiful. I went here too. It's like Machu Picchu. It's here in the Andes. Very beautiful. The Alps are in Europe. That's like in Switzerland and France and Italy. I've never been to the Alps. And the Himalayas in Asia are over here. That's like where Everest is. I've never been to the Himalayas either. Okay. Alright. Here we see one way that plates form, right? When the tectonic plates push into each other, like we saw on the last page, they push together, and then this kind of folds together to make mountains like this, okay? Buckle, the rock layers buckle. Oh, why can't I move? Yeah, that's this one here. Fold mountains. Fold mountains are formed where two plates press together. The zone between crumples upward to form a range of mountains. The Himalayas began to form 50 million years ago when a tectonic plate carrying India crashed into Asia. Okay, so India and Asia, right? They crash together like this. Here's India, and here's the rest of Asia. They crash together, and it pushes, and it makes it fold like that. Right? We see this example here in this experiment. You take the towels and the books, you push it together, and you can see how it folds like this. Right? That's how the Himalayas are formed. That's how Everest was formed. Here's another kind of mountain. Volcanic mountains. The molten rock erupted by volcanoes eventually builds up to form a mountain. If a volcano gives off a thick, sticky lava, it forms a steep-sided cone. Other volcanoes erupt runny lava, which forms a low dome. A low dome will be a shape like this, right? Some make low ones like this. If it's stickier, then it can make a cone like this. An undersea volcano may erupt so much lava that the cone rises above the sea to form an island like Hawaii. And Hawaii is a really good example of a volcanic mountain, right? Just like this. The lava comes up, right? Hawaii is a big volcano. Lava comes up, and then dries, and comes up, and dries, and comes up, and hardens until it makes a big mountain, right? The lava is always coming out of it. Alright, so here we learned about different kinds of mountains. How about you guys tell me? What's the tallest mountain you've been to? Start with a question about you. What's the tallest mountain you've ever been to? Hyunwoo has never been to a mountain? You've never been to a mountain, really? I've been to lots of mountains. Let's see. I like this one. I like Mount Washington. I went to Mount Washington. It's pretty tall. Look at this. I climbed up here. It's pretty big. Oh no, Mount Washington, Oregon. Yeah, Mount Washington, Oregon. Also Mount Washington in New Hampshire. I've been to both. 2 different Mount Washingtons. Oh, Sorak. Sorak-san. I think we spell like this. Spell like this. Yes, I've been here too. I love it. I think it's very beautiful. Very, very beautiful mountain. I've been here too. I loved it. Wow, so pretty. Okay. Anyone else? Oh, Montserrat Mountain. Ooh, very pretty mountain also. I've been to some mountains in the south of Spain, but never to Barcelona. I've never been to Barcelona. Very cool. That's very pretty also. I went to the Andes. I took a train through the Andes. It was very pretty. Taking a train. I've been here. I went here. It was really, really cool. Very, very cool. Okay. Alright. So, we talked about plates. We talked about mountains. Let me ask you a couple of questions now. Have it. TAAL volcano. What is that? Ah, in the Philippines? Oh. Whoa. Really? That looks really cool. Very, very cool. Wow. Really? Very pretty. Cool, cool, cool. Cool, 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 cool. Never been there. Never been there either. Alright. Awesome. You've also been to Sorak-san. Yes. I love it there. Okay. Let me ask a question here. Let me ask a question with horses. Oh, horses at the volcano? Oh, really? I've never ridden a horse either. Never in my life. I've never ridden a horse. I've always wanted to try. It seems like fun to ride a horse. Really seems like fun, but I've never done it. I've never ridden a horse. Okay. So, let's quiz you. Okay. Let's quiz you. What's a quiz I can ask? What's a quiz I can ask? How about this? Why are some volcanic mountains steep while some are low? Oh, you rode horses and went to a volcano? That's so cool. I'm so jealous. I want to do that. I want to ride horses and go to a volcano. That sounds like lots of fun. I'm very jealous. Riding horses and going to a volcano. Sounds perfect. Perfecto. Riding horses, going to a volcano. Answer my question. Why are some volcanic mountains steep, but some are low? Some are steep, but some are low. Nature-made mountain? Yes, they're nature-made mountains, but you have to explain why are some steep and some are low. You gotta tell me. Gotta tell me. Not because nature made mountains. That's not an explanation about why. Some are steep like this, remember? Some are tall and sharp like this. And some are low and round like this. Why? Why are some sharp and some are low? What is the difference? Which one's older? The new? No, that's not why. Sometimes mountains can get low when they get old, but here we're talking about when they're first made. When they're first made. Right? It says in here. It says here. Who can explain to me? Why are some volcanic mountains tall and sharp cones, but some are low and round domes? Who can tell me? Who can tell me why? Who can tell me why? Low mountains only because of earthquake? It doesn't say anything about earthquakes in here. Somebody read this one. You gotta read this. It says right here, read this. Read here. Right? Read this, read this. This tells us the molten rock erupted by volcanoes eventually builds up to form a mountain. If a volcano gives off thick, sticky lava, it forms a steep-sided cone. Other volcanoes erupt runny lava, which forms a low dome. An undersea volcano may erupt so much lava that the cone rises above the sea to form an island like Hawaii. So we see here why some are steep and some are low. It tells us. Volcano erupts different heights? No! No! Read this! Are you guys reading this? Let's see some correct answers. I narrowed it way down to you. I narrowed it down for you, so answer it. Answer it. Answer it, answer it. Answer it. Alright, so Ryan gave us an answer. When the mountains erupt runny lava, then it makes low mountains. Right? If it's thick, sticky lava, then it makes steep cones, right? That's the difference. Oh, this is very cool. Very cool picture. I like that. Okay. Right, we think about it like this. Right here, let me draw some ground. Here's some ground. Here's the earth. Let's draw our two. I'll do blue lava so it looks different, okay? So lava comes up here. That's too big. Lava comes up here and it flows really well. It doesn't stick. It doesn't cool down very quickly, and it just flows away. And then it hardens. It takes some time to cool down. Then the mountain's going to go like this. If it's slow to cool down, then it's like this. But if it comes out, and it hardens really quick, it turns into rock really fast. It's sticky and then hardens right away. Then it's going to make this kind of sharp mountain like this, right? So this is like runny. Right? So this is like runny, and this is sticky, right? Make sense? It'll make different shaped mountains because of that. Alright? Does that make sense? That makes sense, everybody? Okay. This one will be, so we'll have tall ones like Mount Fuji. And here we'll have low ones, like maybe Pompeii is like this. I don't remember. Or we have dome volcanoes, like these low ones. Like, wow, these are so cool. Wow, so cool. I want to go to see a volcano. Wow. Wow, so cool. What? This can't be real. Lava dome fountain in Hawaii. Wow. Okay, anyway. Some volcanoes, right, are very low, wide volcanoes. Whereas other ones are very steep and sharp, right? So these low dome-like volcanoes are from the lava coming out very slowly, right? And we have our cone volcanoes. Our cone volcanoes are the sharper, pointy ones like this, right? And that's from the stickier lava. Wow, what is this? Cinder cone composite shield volcanoes, right? Okay. Right, so we have these different kinds of volcanoes from the different kinds of lava. Okay, helps us understand. Okay. And we talked about this, the fold mountains and the block mountains. So any other things? What else is there? Okay, we also talked about these things. We talked about tectonic plates. We talked about tectonic plates and talked about volcanoes. Any questions? Do you have any questions? Sean says no. Sean knows everything about rocks, volcanoes, and tectonic plates. He is a geology expert. He went to college to study geology. He knows everything about rocks. That's amazing. Wow. Ryan Chu, you guys are experts, professionals in the geology field. I am so impressed. Daniel too, you know everything about mountains, everything about tectonic plates. Oh. Very impressive. Very, very impressive. Okay. None of you have any questions. You know everything about volcanoes. That is amazing. Amazing. Okay. I guess I have to ask some more questions then. Okay, I gotta ask some questions to you. Okay. Someone tell me, what are convection currents? Explain them to me. What are convection currents? Don't copy a sentence from the reading. Don't copy it. I want you to tell me with your own words, what are convection currents? Somebody tell me, what are convection currents? Who can tell me what are convection currents? Who can tell me? Who can tell me? No, convection currents is not lava coming out of the ground. Alright, a water and magma cycle. Yes, remember convection currents. Convection. Oops, I misspelled it. Alright, remember convection currents is a circular flow. A circular flow of something is hot, comes up, and then it gets cold, and then it comes down, right? There are convection currents in a teapot. In a teapot, we have convection currents. It gets hot, and then the cold stuff goes down. We see, if you look inside boiling water, you see convection currents like that. You see convection currents in the air like this, right? The sun gets hot above the ground from the sun. It comes up, and it cools down, and then the water air is cold, and then it heats up on the air again, right? So we have here, during the sun, the wind blows this way, right? And very common. We have convection currents all around different places, right? And the stove, and then under the earth, like we were talking about. So under the earth, like this. Right? Hot water goes up and cold water comes down, yes, right? So, and same with lava, right? It comes in here, the lava gets hot and comes up, and it cools down because here the crust, we call the lithosphere, the crust is colder, so it cools down and goes down. And here it's very hot, so it gets hot again here, and then it comes up, and then it cools down, and then it gets hot like this. So we have these circles like that. Those circles are called convection currents. Right? These convection currents is the movement of the liquid. Right? Those circle currents are called convection currents. It's a very important idea to understand, right? Here we even see a convection current in a room. Okay? Here we have the radiator. This air gets hot. It comes up here. And then it cools down by the window and it sinks. And because this air is coming up, this air gets pulled in over here. And then this air heats up and comes up and comes over here and then cools down and comes down here, right? So even in a room with the window closed, you can have a convection current. You can have wind in a closed room because of the heat and the cold, right? Makes the convection current. Just like that. Okay? Alright. So, anything else? Right? Convection currents. We see it in weather too. Hot air comes up, cools down, makes it cold air. We see it in all parts of the world, all parts of life, we can see convection current. Convection current, I'll show you a visual, a video. Right, so we can see a good short convection current.
How do convection currents work? The inside of the Earth is made up of layers. This is the core.
So we have the core.
This is the crust.
The crust.
And the biggest layer in between them is called the mantle.
Mantle.
The Earth's core is extremely hot. It's about 5,000 degrees Celsius. It heats the rock in the mantle, which rises to the crust. Here it cools and becomes more dense, moving back down towards the core again. This cycle of heating and cooling is called a convection current. When the rock is hot, it rises. When it's cool, it falls. Convection currents are the driving force behind plate movement.
I want to show you a better one. Alright. Here's a good one. I'll show you the convection current.
Welcome to Moo Moo Math and Science. In this video, you will watch a on the other side, and let's
Right, so this one's hot,
happens,
and over here it's cold, right?
Currents.
So here we have the
Obviously,
hot
the
one
red is beginning to rise
coming out,
upward, and you can begin
rising.
to see blue sink downward.
Right?
And we'll see if we
The hot liquid comes up. The hot liquid comes up and up and up. I wish I could make the video go a little faster. Hot video comes up and it pushes.
Okay, now you can see the blue water, which is cold, is sinking down.
Blue water sinks
and
down.
the red water, which is warm, is rising up. As the red gets to the top, it will begin to cool and eventually go back down. And if
we
the
have
blue
some red
water
coming down too now.
Cools, warms
The
up,
red is
then it will
cooling
rise
down,
back up.
and now
So as
it's
you can
coming
see,
down.
these are how convection currents are formed.
So we can see it makes a circle like this. Okay? It's just the same
Thanks for
thing,
watching, and Moo Moo Math.
the same thing in the earth, right? We saw here. It's hot and then cools down and goes. Right? And these currents are what pushes the plates together just like this to make mountains, because of these currents pushing the plates together to make these mountains. That's how the Himalayas were made. That's how Mount Everest was made, from the plates pushing together like that, or from the fault lines here cracking and falling down, leaving the Black Mountains. Okay? Alright. So, learned a lot today. Covered lots of things. Hopefully you learned a little bit about the tectonic plates, about magma, about very important convection currents, very important. Learned a little bit about mountains, mountain ranges. Usually mountains aren't just by themselves, but they're in groups of mountains. The Black Mountain kinds, right? Learned about Black Mountains. We learned about fold mountains, and we learned about volcanic mountains. Right? We learned about volcanic mountains, and the two different kinds here. Well, there's more than 2 different kinds, but these general, if the lava is very runny and smooth and flows wide, then the volcano will be low like this. And if the lava is sticky like this, then it will be tall and pointy like this. Okay? Well, if you don't have any other questions, I guess that's it for today. Finishing everything up. Hopefully you learned a bit. Good. If you have any other questions, you ask your questions. Otherwise, that's it for today. That's it for today, and you can say goodbye. Okay? So, hopefully you learned something. Goodbye. Or ask questions. You ask questions, I'll answer them. Okay? Or you can just go. Okay? Bye, everybody. I will see you next time. See you next time. Goodbye, goodbye, goodbye. Goodbye.